Hello again and welcome. I'm going to spend the remainder of the day going through the rest of the parts that this friend of mine had shipped me. One of the parts he had included was this plug-in here. This is a option L1 F2, and again that F2 option was required for that SCSI communications that I had mentioned in the first video. Now this plug-in I've already gone through and checked out. It actually is 100% functional, looks in good shape. You could tell there's a little bit of difference between that plug-in and mine. Notice the finish on this one. So this has actually got a painted surface to it. When we look at the older version, this is just aluminum. So this one is a serial number 21995, and this is a serial number 29157. So this is quite a bit newer. Again, these plugins are a 2-channel and they're rated for 500 megahertz at 1 gig of samples per second. Of course, there's an adapter that you could get. This is looking at it here, and this plugs between the 2 channels and it basically interlaces the two. So this is essentially a 500 picosecond delay line. I had originally made my own. This is what it looks like, because I couldn't find one of these. So this connects to the front, just like so. And then you would plug in your coax right here. So this would be your test probe in this case. And that'll give you an effective sample rate of 2 gigasamples. So I showed you another plug-in yesterday in my older oscilloscope. This is the same one, but the latest version of it. Again, you can tell that by the silver paint. This is a serial number 21385. You can see property of Lacroix Corporation. So the way I obtained this is there was an employee that worked for Lacroix, and they had an employee sale. So he went to that sale and purchased quite a bit of the old 7200 equipment. So I actually had the test jig that they were using to align some of these plugins originally. So I've since gotten rid of a lot of that older stuff, but that's where this plugin came from. I had 3 of these that I had purchased from them. 2 of them I still have. I gave the other one away. This is the 1990 catalog for Lacroix. And we can see right in the opening page, this is the Lacroix timeline. You can see in 1964, this is when they were founded. And in 1989, they introduced the 7200. Again, a very innovative scope for its time. In the first video I'd mentioned that the 7242 that I had a lower bandwidth, and we can see here it was rated for 400 megahertz, and you can see it has a sample memory of 50,000 points. Contains both a built-in hard drive and a floppy drive. So the original one uses MFM. The one that I showed you yesterday came with an old K-Lock drive. I had replaced that with the Seagate ST225. Unfortunately, the scope won't just support any MFM drive. You have to use the ones that they had designed their software for, and it didn't support the Seagate drive, unfortunately. So I had hooked the 2 drives up to a logic analyzer and tried to see what was going on and why the Seagate drive wouldn't work. And I modified that Seagate drive to basically mimic what the K-Lock was doing, and that's how I got that drive running. So it's been quite reliable. I think I purchased that scope probably 15 years ago. And it really hasn't given me a whole lot of problems. I keep it around because if I'm working on something that is really high risk, like for example a high voltage scope probe, or I'm playing around with ignition sources or something, I'll typically use that oscilloscope. The reason is because I figure it doesn't really owe me anything at this point. If I damage it, I'm not really out a whole lot. The other thing too is it's more than capable of looking at high-speed signals like that. So this is looking at the mainframe that they had sent me. It actually looks in fairly good condition. It's got a rattle, Something's loose in it. So this is looking at the back of the instrument. You can see some of the cards that they had supported. We have a serial parallel card. This one happens to have that. Here's the GPIB. Again, this is supported. This is the trigger card. That's this one on the end. Then there's a reference clock. Unfortunately, this one does not have that. It does not have SCSI. I don't believe that that's what this is. I think this might have been a floppy controller from what I remember. And then they showed this Ethernet card as well. I have never seen Ethernet supported by one of these mainframes. Again, this is just a PC. This could be a 386, a 486, I really don't know. The serial number on this one is 21692. In the previous video, when I showed you the 7200, that unit has 5 fans across the back. You can see this one only has the 3. These 2 are for the 2 plugins, and then this is for the rest of the chassis. Airflow enters through the bottom of the unit, and this is looking at it from the front. Again, no cracks or anything in any of the plastic. Typically what would happen is this bezel would be broken out of here. It looks fairly clean. There's no indication who owned this scope. I'm sure I could go back to LeCroy and they would have a record of who purchased it. Looks like it had been calibrated by LeCroy. Well, let's go ahead and we'll take this thing apart and have a look at it. Like I said, it's got something that's rattling in it. I'd be a little concerned about just turning it on anyway. It could do a lot of damage to it. There's really no point. Cover looks really good. This here would be the power supply for the instrument. You can see the old monitor, CRT style. These use an IDE type drive. These use a Phoenix here. This is typically the one that melts. So on the far back we can see this is the video card. This is their proprietary controller board. And next to that, this is the floppy controller. And the GPIB controller here. And this is their IDE controller. They have a couple of slots left. You can see they are using a Intel 486-33, and I believe this is the same motherboard I had with my older unit. This is using the Symphony chipset. I tried changing out the processor in my older unit. I tried installing a Cyrix part and then later an AMD. And I think I ended up going with a 486 DX4 100 megahertz. So essentially it's an overclocked version of this. And there were some gains if you're running a lot of math that's done with the CPU, and that actually did help. Doesn't look like anything's been burned. Alright, so I've been making some dent in things. This is an old PC. This one was made by Digital Equipment Corp. This was sold by MicroAge in 1993. This is a 486, similar to what's inside of the scope. You can see here I have this SCSI card. This is set up per the manual, so I was using this PC to communicate with my higher end scope. The manuals for these scopes are available, so you can look this up online, but basically you had to have the plugins with the F2 option, and essentially You would run a cable between the oscilloscope and the card here, and essentially this became the high-speed data transfer between the scope and the PC. This is the timing board option. So there's 4 cables that connect here, and then these run up to the backplane. There's these special cables that connect between this and the backplane. So you can see this is a 7200 AR clock, revision B. So I think what we're going to do is go ahead and install this into this computer while we have it apart. Alright, this is looking at the backplane here. You can see the back of this is filled up, so I can't really get a good angle to show you how this works, but essentially there's a spare hole. I can shoot it from a different angle here. Alright, so you can see maybe this one here. That one just goes right here at the end, and it just snaps right there into place. This is the other one that we installed right here, and the other 2 connection points go here and here. Right, so that timing card is using this pin above my finger and this one over here. Now to remove these, you have to have a special extraction tool that kind of wraps around this. These pins have, it's like a metal sleeve that wraps around them, and it allows you to push those into these sockets, but then once you get them in, they lock into place. Right, so I just ran my cables up and around, and you can see I've gone ahead and installed the card. This one here goes to J1. This one goes to J2. This card's ordered a little funny, so it's 1, 2, and then 3, 4. So this goes to 3, and this one goes to 4. Just like so. And that's all there is to it. Like I say, the only option now that this does not have is the SCSI controller. Normally we would slide that into this slot up here. Now on the PC side, I used an AHA, I think a 42. Guess again you'd have to look that up in the manual, and that seemed to work fine. Unfortunately, I didn't save any of the original SCSI cards for these, so I can't install that feature into this oscilloscope. Alright, so I looked through my pile of CPUs, and unfortunately I did not have another 486DX4. So I'm just going to leave this with the 33 MHz processor in there, assuming it works. I have not bolted this back together yet. I think what I'd like to do is let's just see if it'll power up. Sounds pretty dead. Alright, so I think it's this switch here. Has to go down. And let's try it now. Nope. Alright. Alright, so I've been going through the power supply, and I think we are ready to give it a try now. Just got our little switch here off to the side. Hopefully this thing will go ahead and fire up. Jeez. Yeah, I'm gonna say the hard drive's dead. Holy smokes. Alright, well, at least the power supply is coming up now, but I think that drive's gonna have to come out of there. I suspect that this is the original drive out of the oscilloscope. You can see I have some other ones that I've saved throughout the years. These all came out of a 7200. You can see they're all a Quantum Pro Drive LPS. So I had upgraded all the scopes that I had built. I think what I'll do is just go ahead and install one of these. This is also a Quantum Pro Drive But you can see the circuit board is like a half-length card. So I'm going to try using this one to bring the machine up. It still may have the original OS on it. So I've got the monitor attached. Alright, let's just see if the hard drive is going to grind or not. But it sounds a lot better. Yep. Oh. Check it out. What I'll do is just let this thing run for a little bit. We'll make sure that the power supply is going to hold up. That's a good start. Pretty happy with that. So here's the next problem. So these will all have to get replaced. Fortunately, we have 3 of these, so we've got enough to change out the 2. Alright, so you can see I have the front panel back on. Got 2 new rotary switches in here. Scope's starting to shape up. At least it's starting to look like a scope. It's going the same as the other knobs. Let's give it a little snug there. Wipe off some of the crud off of those as well. Alright, now what we can do is go ahead and install the latest software. Looks like we got another problem. I'll tell you, a big pain. So I swapped out the floppy drive, but to do that you have to basically pull the hard drive out because there's not enough clearance to get this thing out of there with the hard drive in place. So yeah, everything works now. This is the diagnostic disc. See if that'll boot. Well, it looks like the new floppy drive works just fine. It's the revision of the motherboard, so it's the Symphony chipset, SL82C461 Rev 6, 82362 Rev 1. You can see I have my two newest plugins installed. There we go. Get a little bit of color. You can see I've applied a jumper between the input and output. I've set channel 2 to output a pulse. And this is the delay through our coax. This is roughly 2 nanoseconds per division right now. Right, this is currently 500 picoseconds per division. This is 200 picoseconds. This is 100 picoseconds. And you can see this is 50 picoseconds. You can see we're 100 picoseconds per division. Looks like our rise time is roughly 200 picoseconds. I'm not going to torque any of this. And what we'll do is turn on our second pulsar. There we go. Alright, so the green trace here, this is channel 1 of our first digitizer, and the blue trace is the second channel of the digitizer. And again, you can see we are at 500 picoseconds per division right now. Currently the rise time is 300 picoseconds. Compare that to the 200 picoseconds that the other digitizer was showing. Again, the bandwidth of this digitizer is roughly 500 megahertz compared to about 4 gigahertz on this one. These are my Handtech PP150 probes. Let's just go ahead and plug that in, and we'll set this guy to DC coupled, and we'll go ahead and slow this down. So this is looking at our calibration pulse. You can see it's at 1 kilohertz, 1.0001. The period is 999.99 microsecond, 500.14 microsecond width. Rise time's a little slower. This is about 500 nanoseconds. You wouldn't expect a lot out of our calibration, but yeah, looks like it's working just fine. Of course, our probe needs to be compensated for this input, but no problem. There you go. I still have to install the back cover, put the top cover on, but that's pretty much it. I would say this has been a successful weekend getting these old scopes repaired. So a lot of problems with this oscilloscope, but fortunately I've saved enough parts over the years to be able to resurrect it. So, I think that's going to be it for this video. Hope you enjoyed it. Till the next video. Later.